El Nino expanding as warm water builds over the equatorial Pacific. I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, June 11th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time. No hype.
Be sure and like and subscribe. Ring the bell. You get automatic notification when the videos are posted, typically on Sunday evenings. And if you'd like to make a contribution, hit the special thanks button down below, the heart with a $sign in it. It helps our operations move forward. And with that, I'd like to thank last week's contributors: Peter Beldman, Sporman, Jason, thank you, Captain Skeezer, Elliot Harris, Devlin Millay, Aaron Korn, Ricardo Durate, thank you so much. We really appreciate your generous contributions. And with that, let's get to work. We'll start off by looking at significant wave heights for the South Pacific Ocean. We see a little area of disturbed weather, seas in the 24-foot range, aiming pretty well to the northeast. Probably not large enough, though, to really get enough traction to generate meaningful swell. Typically, you want 26, 27-foot seas. You can at least eke out maybe 15 seconds a period from that. Anything less than that, swell decays really quickly, making its way north over the long distance up into California and Hawaii. So effectively, not a whole lot going on at the moment. Looking at a few buoys, we'll start at Point Reyes, California buoy 029. That's the North California buoy. We're looking at all the energy that's hitting the buoy right now. From anywhere up at 33.3 second period, that's super powerful, long energy, which there is none, all the way down to 5 second period, just pure wind chop, not even really surfable. We see a bump here in about the 9 second period range. That's wind swell. We see a little bit of energy somewhere in the 14, 13 second and out that's small southern hemi energy. You put that all together, try to sort it out. Clearly there's a bump here, so mainly the wind swell component of this. 5.3 feet at 8.8 seconds. So 306 degrees, that could make surf that's about 4.6 feet on the face, but it's not even that big. And then there's the southern hemi swell, 2.7 at 12.8 seconds. This says 280 degrees, but I think most of that's, well, even that might be a little bit much for southern hemi, but waist high, something like that. So then we go down to Santa Cruz. All this buoy, 254, the Point Santa Cruz buoy, for the most part is protected from most of the northwest wind swell. You see the bump here at like 13 seconds, 0.9 feet, something like that. And the wind swell, pretty much not there at all. Primary swell, 1.7 feet at 13.2 seconds from a 211 degrees. And then the wind swell trying to eke in there too. That's surf of about 2 foot, and I think the waves are maybe waist high, something like that. Down in Southern California, we're just going down to San Diego, the buoy off of there, buoy 191, the Point Loma South buoy. We see fragments of southern hemi swell energy. Biggest fragment is 1.2 feet, everything else half a foot or something like that. Primary swell, 1.7 feet at 13.4 seconds from, it says 240, but that's actually more southerly than that. Surf size, 2.3 feet, and some secondary energy, 1 feet at 17 seconds from 184 degrees. That's about 1.5 foot surf. Yeah, there were some chest high sets maybe at top spots earlier today, so not too far off the mark. And then finally we go to the Lanai buoy, number 239, south facing. We see again the same pattern of just scattered tiny bits of energy, but nothing really meaningful. Primary swell, 1.2 feet at 13.2 seconds from 199 degrees, and some secondary swell at 0.7 of a foot from 16.5 seconds from 211 degrees. Altogether, 1.5 foot surf. Yeah, there were some thigh-high sets, something like that on the South Shore earlier today. So, in short, not a whole lot of surf hitting at the moment. So is there any hope on the horizon? Let's go take a look down south. We're going to go back a week ago, Monday, the 5th of June. Really, there's a gale. It was approaching Chile and Patagonia, but east of the Southern California swell window. I think San Diego's like at 117 west. Anything east of there, just It becomes a swell for Peru and Chile and Central America and maybe portions of Mexico, but certainly not the U.S. West Coast or Hawaii. Another little gale tried to push under New Zealand with 23 or 4 foot seas and pushed across the southern hemi about like that. And secondary gale built on Wednesday, the 7th of June with 26 foot seas. But again, this whole very flat west-east push does nothing to get energy radiating up to the north towards Hawaii or California. The focus then really becomes South America and Central America. And there will be swell probably from these systems. Yeah, seas were 34 feet on Thursday, but again, nothing expected for the U.S. mainland. We're into Saturday and Sunday, things really go quiet, and that's where we are right now. So no meaningful swell was generated so far this week. Right now, we're going to start looking at the jet stream, looking for the future. Is there some hope? With El Nino starting to develop at some point, the southern hemi jet stream should respond. Now, it's not you read the press and all that and they kind of hype things up, but it's not a quick, instant correlation. Oh, we have El Nino and, the jet stream starts raging. No, it's not like that. It takes a couple of months. We're about a month and a half into this process. I think it's going to be maybe till the end of July, something like that, till the jet stream, especially in the southern hemi, really starts responding to this developing El Nino situation. And all the details, we'll get into that in a minute. But looking at current conditions, we're looking at the jet stream. These winds are up about 30,000 feet. They help support the formation of gales. When those gales form, help direct their track. We're looking for a trough, a push in the jet to the north. We see it right here. That's good. That helps create a clockwise flow aloft and down at the ocean surface. That's the hallmark of low pressure, and of course low pressure, if it's strong enough, generates winds that get traction on the ocean surface. They start generating seas, raw waves. Those seas, as they radiate away from the fetch area, eventually get groomed and turn into swell, and so when it hits your beach, turns into surf. So we have a trough offering some potential here for low pressure development. As we get further into Sunday, though, notice the wind energy in the trough kind of backs off. By Monday morning, we're down to 100 and maybe 110 knot winds. You really want 130 knot winds, something like that. And then the trough starts pushing the San Diego is about 117 west, so this starts pushing out of the Southern California swell window as we get into Monday night and Tuesday, and that is the end of that. Now notice wind energy is really supposed to start building here in the northern branch of the jet. It doesn't really do anything for surf development per se, but it might suggest that maybe El Nino is trying to get a little bit of a push in the jet stream here. It's really this southern branch that does all the action in terms of swell production, and you see it very weak, not doing anything. We continue the week into Friday, and then Saturday, the 17th of June, another bit of wind energy starts peeling off the main branch here, trying to lift north, maybe creating a bit of a trough here. Now, the ice line's about 65 south, something like that. It's got to get north of that ice line, and it's supposed to do that as we get into Sunday, but then the jet kind of fades some too. So maybe there's some hope, but no glaring red signal that some major swell or even a moderate swell is going to immediately become generated. But let's confirm that point. We're going to dig down a little bit deeper into the atmosphere. Down at the ocean surface is surface level pressure, surface level winds. We see the initial low pressure system today, Sunday the 11th, producing 35, 40, maybe a tiny pixel or two of 45 knot winds aimed to the northeast, and there we go. So we get into this evening, actually right about now as we're recording this, 45 knot winds lifting off to the northeast, but then notice the low starts falling southeast. Secondary fetch produces 35 knot winds on Monday afternoon, and then, well, again, the line is right here. The low moves out of the Southern California swell window. Certainly good for producing surf for Peru, Chile, and maybe up into Central America, but nothing for the U.S. mainland. Secondary fetch building, but again, the line right here, the 117 west line, all the action east of there. So this is purely a Peru and Chile sort of swell producer. A little bit of fetch forecast on Wednesday night into Thursday. Only 35 knots, though. Lifting off to the northeast, if it was 40 to 45 knot winds, maybe we'd have a prayer, but it doesn't look like it. Now we know there's another trough starting to form, and here we go. We start to see some evidence of it. So we get into Saturday, and then Sunday, 45 knot winds aimed off to the north, lifting a bit to the north. This would be good, and this actually looks like a decent one for Hawaii. Hawaii's been left out of whatever meager swell production there's been this summer. Hawaii's been pretty much way too far west and out of the swell window. So as we get into Sunday night and Monday, maybe some hope for the islands. Let's go take a look at the effect of these winds on the ocean surface. So here we are, significant wave heights for the South Pacific Ocean. Now this chart is the highest 1/3 of the waves. I call them seas. Officially it's the significant wave height. Highest 1/3 of seas for the ocean. And we know there is a trough and a gale trying to develop here in the far southeast Pacific with 20, 22, 24, maybe 25 or barely 20. There we go, 26, almost 30-foot seas Sunday evening, but pushing off to the east, not really lifting northeast. This back tail here has 26-foot seas lifting off to the northeast. So maybe there's some hope there, and this whole thing pretty much pushes out of the Southern California swell window as we get into Tuesday. But certainly production potential for Peru and Chile as this thing pushes off to the east and continues sort of percolating and circulating into even Thursday and Friday, but really nothing for California. We're keeping our eyes here on the central South Pacific as we know some sort of a gale is forecast. And there we go. We have, what is that? 25.6-foot seas. See the little plus sign right there? Plus sign there. This is the highest seas over this whole image, and it's right there located at 42.75 south, 158 west. You get it. And also this tells you where the, let's see, the X is, and I don't know that you can really see it, but I think, oh, it's right off here. The highest winds are at 43.1 knots at more or less that same location. So some hope. Seas build up to theoretically 32 feet as we get into Sunday, but, you know, beware, this is a week out. And then moving off to the east from there before the model fades out. So I'd give the odds of this system actually forming quite low at this early point in time. Local wind forecast for Hawaii on Sunday trades 10 knots off the U.S. West Coast. This eddy flows, so you can see it. High pressure here, circulating clockwise. Heat low, the red lines inland, generating a counterclockwise flow. Right here, the Cape Mendocino tends to be like the point that does this, especially in the summer. You get a tightening in the isobars between the two systems. It makes kind of a Venturi effect, if you want to call it that, and winds sort of get amplified just by geography of the land and the pressure pattern. 25 to nearly 30 knot northwest winds generating some wind swell, but locally the winds, it doesn't show it on this model, but they're actually blowing out of the south along here, feeding up into the low. So relatively quiet pattern. You have the wind swell generating machine here, but relatively light winds from Point Conception northward. That's good for producing wind swell and something to ride if you're desperate. As we get into Monday, same thing, but even the gradient and this pressure pattern fades out. Trades 50 knots for the Hawaiian Islands. As we get into Tuesday, again, the eddy flow for California. Trades 15 knots for the Hawaiian Islands. Wind swell production starts picking up again on Wednesday with 30 knot winds early. I think they build barely 35 knots on Wednesday night. Again, limited to Cape Mendocino with the eddy flow along the coast. Trades at 10 to 15 knots for the Hawaiian Islands. Thursday, again, the eddy flow, south winds for California, but wind swell production increasing a little bit as 25 and 30 knot winds off Cape Mendocino. Trades for the Hawaiian Islands. Friday, the gradient starts fading for California, and trades continue pretty much standard, usual 15 knot thing for for the Hawaiian Islands. Saturday, gradient continues, but notice northwest winds start pushing down the California coast. The eddy flow breaks up because high pressure building stronger here over the Gulf of Alaska, pushing into the coast, pushing the low further inland. And as we get into Sunday, just more of the same thing. Maybe some wind swell to result, but looks like pretty much of a mess for California. Trades continue, maybe a little bit stronger for the Hawaiian Islands later on Sunday, the 18th of June, at 15 knots. So wind swell, and that's about it. No particularly strong winds until we get into next weekend. For the hikers that are maybe doing the JMT or attempting to do the JMT, so we were up there on the JMT in the Yosemite area on earlier this week. Hard snow line at about 8,900 feet on east-facing slopes, southeast-facing up near Clouds Rest. You know, it was fine hiking until you hit about that 8,900 foot level. And then it was 5-6 feet of snow, and pretty hard conditions beyond that, pretty well sun cupped up. The snow itself, not too bad, not too wet. A lot of water running down below that. The waterfalls, of course, going crazy. If you follow us on Instagram, you saw some of the pictures I posted there from going up Vernal Nevada Falls and around Yosemite Falls. Still lots of water, a little bit past peak, which was maybe a couple of weeks ago, but still impressive amounts of water. Certainly not something to be played with, but certainly if there's no surfing, you have nothing better to do. Worth a trip up there just to see it. This is like a once-in-a-50-year kind of event. So for a lot of people, once-in-a-lifetime sort of waterfall experience. Worth the effort. Anyway, and then now if you believe the models, theoretically, this afternoon into this evening, another 6 inches of snow forecast. This is the Pacific Crest Trail where it crosses Tioga Pass Road. And you see, theoretically, some snow. Don't really believe it's going to happen. Maybe above 10,000 feet. And there's still plenty of snow up there on the ground. So what's a couple more inches, right? Okay, snow level. Now we're talking about what's the deal on the melt of the snow, the big melt they're calling it. All right, so the reds are temperatures well above 32 degrees. The gray is like a sleet line. 32 degrees is right where the white and the gray intersect, so at about 10,500 feet. Supposed to continue that into tomorrow, and then temperatures start warming in the High Sierra with the freeze level going up to about 12,000 feet, then 12,500 feet on the, we'll say the 14th through about the 17th or 18th. And then temperatures, theoretically, this morning it wasn't showing this. Now this evening, boom, temperatures up to 14,000 plus feet, which would mean, or above freezing temperatures, which would mean a quicker melt of the High Sierra snowpack, especially above 10,000 feet, or that even that 8,900 foot I was talking about earlier. And that's supposed to be starting on the, we'll say the 18th and continuing beyond that. So putting all that together in some sort of a graphic that makes sense, we're looking at surf heights. We're in Half Moon Bay, just a general representation of Northern California. And surf heights in the 3 to possibly 4 feet, sometimes less. Basically all just wind swell. We can look at it here. 4 feet, 3 feet at 10, 11 seconds, all from that gradient. Then theoretically, maybe a week out or towards next Sunday, maybe a little dribble of southern hemi swell. From that low that's developing right now on the edge of the Southern California swell window, 1.6 feet at 14 seconds, something like that. That would make surf in about the 2.5 foot range. So something to stand up on, but certainly nothing more. Santa Cruz protected from the wind swell waves, 3 foot, and that's probably pushing it. And then we see a little bit of 2 foot surf beyond that. Swell, well, it's all wind swell, 2 to 3 feet at 10 to 11 seconds. Then that southern hemi swell, 1.4 feet at 14 to 15 seconds. So pretty much the same thing, just less wind swell relative to Santa Cruz. Going down to Dana Point, a good proxy for Southern California surf, pretty much 1.5 foot, pushing up to 2 foot. You can pretty much see where the southern hemi swell, small as it may be, starts showing up. Looking at the details, 1.2 feet. Well, this is all background southern hemi swell of just small proportions. What do we say? Surf size 2 feet. So yeah, rideable, but nothing more. Then the new swell comes in. Where is that? Somewhere on Friday. 1.2 feet at 15 to 16 seconds. So basically just a bump in the period. And that gives you a little bit more size, but no significant swell forecast. Then for Maui, and the same for the south shore of Oahu, surf size is really small, 1 foot to 1.5 feet, something like that. Swell sizes, well, it's all pretty much wind swell. You see bits and pieces of 14-second period energy, but the swell size is all like 1.4 foot or 1 foot, something like that. So really small surf, nothing significant forecast for the next week. We do have a tropical system, Typhoon Guchol, I believe is how it's said. Winds 80 knots off of, approaching south of Japan, a little bit east-northeast of Taiwan. The good news, or the interesting news here, is that it's recurving off to the northeast. This is the second system. Molar, I think it was last week, did the same thing. Now, that didn't develop into anything of any interest. This probably won't either. But the fact that they're not pushing inland here, maybe we can show it this way, inland into Japan or Korea or, Vietnam or something like that, is a really good sign. That suggests that El Nino is having influence on the jet stream. The jet stream is building in the North Pacific and redirecting these systems, like I call it recurving off to the northeast. Typically, you don't see that until late July at the earliest, and really it's August, mid-August. I think the earliest I've seen a north swell generated by some sort of a tropical system that recurved, it was mid-August, so we'll say early August. And here it is, barely June, and systems are already recurving. Now, this one, theoretically, if you look at the longer range models here it is supposed to, here's the recurve, you see it off of Japan here, supposed to push towards the date line, which is right here, and of course fade out. Now the GFS model loves to overhype this stuff. It suggests, 22-foot seas and 21 to 22-foot seas on Friday the 16th of June, setting up on the date line. That could certainly produce some swell for the Hawaiian Islands if it were to happen. But again, I think this is way overhyped. It will not happen. And, that's just going to be the end of it. But just to even see the recurve, that's actually a pretty big deal. So we'll keep that in mind. And with that, we're going to take a look long-term, what's going on with the MJO, the Madden-Julian Oscillation, and the El Nino Southern Oscillation. These two weather oscillations are the main determiners or contributors to storm and therefore swell production in the North and South Pacific. So, let's dig in. We're looking for signs of the active phase of the MJO. And what's the MJO? Well, it's this periodic weather oscillation. It traverses west to east around the planet on the equator. The active phase, it has two phases, active and inactive. The active phase on one side of the planet, the inactive phase on the other, and they rotate around the planet like that. All right. The active phase is the one we're interested in. That's the one friendly for swell production and storm production. The inactive phase, not so much. Why is that? Well, the active phase is effectively a low pressure system. All right. And low pressure takes warm, moist air from the ocean surface, sucks it up into the atmosphere. That energy, in turn, can get caught up in the jet stream and energize the jet stream. The stronger the jet stream is, the better propensity for troughs. The deeper the troughs, the better the odds for storm production. Of course, storms produce surf. The other thing with the active phase is when it's moving over the West Pacific, not only can it impart energy to the jet stream, but it also can reverse or dampen trade winds in the West Pacific on the equator. And when that happens, warm water that's typically been balled up in the West Pacific, driven by trade winds, starts to move off to the east. It doesn't move on the equator, on the ocean surface. It falls to depth, follows the thermocline under the Pacific. It takes about 3 months for that ball of warm water to make it the whole way across the Pacific. Eventually, that Kelvin, it's called a Kelvin wave, that ball of warm water, slams into Ecuador, erupts to the surface, and creates a warm water slick. If you have successive active phases of the MJO, they can create successive Kelvin waves, and that is how, with that warming of the warm water and continuous warming of warm water off of Ecuador, then that starts rearranging the jet stream and does all sorts of things. It changes the upper circulation of the planet, and that then ushers in El Nino. And of course, El Nino is great for surf production and water and storm production in the Californian winter months. So we're looking for signs of the active phase of the MJO. One way to do that is by looking at trade winds. Remember, I said the active phase, when it moves over the Pacific, really wherever it is, it dampens trade winds. So we're looking for signs of reduced trade winds. So we're looking at data from the TAO buoy array, a series of buoys strung across the equator used for monitoring El Nino. They also have wind sensors on them. We're looking at the arrows. The longer the arrow, the stronger the winds. The arrows show direction. East Pacific here, West Pacific here, equator here. Dateline, 180 west right there. That's New Guinea there. So the West Pacific right here. I call it the Kelvin wave generation area. If you have reduced trade winds from 5 north to 5 south from about 120, so it's even further east than this, out to about 170 west, you can potentially get a Kelvin wave. All right, so we're looking in the East Pacific here. Trades like, moderate out of the east. Central Pacific, moderate out of the east. Kelvin wave generation area, moderate to maybe weaker. Wish these sensors over here were working, but they're not. But it's not the actual wind speeds that matter. It's anomalies, the difference from normal for this time of year. So normally the trades are blowing pretty good over here in the East Pacific. We're just looking at the arrows here, and I'm looking around the microphone while I do that. Trades look pretty much normal. Maybe a hair bit of a westerly drift to it, so maybe just slightly weaker than normal. Over the Central Pacific, about the same thing, normal to just slightly weaker than normal. In the Kelvin wave generation area, well, just about normal. So no clear sign of the active phase of the MJO at the moment. So then let's go look out 2 weeks. This data from the GFS model, it goes out 2 weeks. I mean, after about a week, it's not believable. And even at a week, at times, it can be not particularly believable. So this is the east-west component of the wind, 850 millibars zonal wind anomalies. Are the winds blowing stronger from the east? That would be the blues. Like here, that would be the inactive phase of the MJO. And the reds and yellows are westerly anomalies blowing stronger from the west. That would be the active phase of the MJO. So we see back in May, and let's get ourselves organized here. Far West Pacific starts about 125 east, so right in a line up there. And the Kelvin wave generation area ends at about 170 west, so right there. So the area we're interested in is right here. This chart represents the whole planet. All we care about is the Pacific Ocean, and specifically the West Pacific, and specifically the Kelvin wave generation area. So today, right here, in the Kelvin wave generation area, we see blues, easterly anomalies. Certainly smells of the inactive phase of the MJO. Good news is what is this, 5-day increments? So about a week from now, well, those easterly anomalies start moving to the dateline, and about a week and a half, 10 days from now, 12 days from now, the inactive phase of the MJO, just looking at this, fades. Notice westerly anomalies building in, filling half the Kelvin wave generation area, and that starts not even a week from now. So whatever inactive phase we're having, it's supposed to be pretty weak and quickly following back by westerly anomalies. Whether it's the active phase or not, doesn't really matter. However, whatever it takes to get westerly anomalies and not have strong easterly anomalies, that's what matters. The other thing that, so past performance here, also look back in May. Very strong active phase of the MJO happened from May 12th to about the end of May. These were not actually anomalies, they were full-on westerly winds in the Kelvin wave generation area. We think that has produced yet another Kelvin wave. I think it's maybe number 6 in a series. Remember, we were talking about multiple active phases of the MJO produce multiple Kelvin waves that can help usher in El Nino, and it takes 3 months for the warm water from an active phase to make it across the Pacific. Well, here is a big Kelvin wave producer right here. If that happened in, we'll say mid-May, let's May to June, July, August, Kelvin wave from that won't even show up till August. So we'll get into that in a little bit more, but just keep that in mind. All right, let's go out and dig a little deeper. All right, so we said the active phase of the MJO is a low-pressure system. Well, low-pressure systems produce clouds, so we have another way of trying to look at some images that depict where and when the active phase of the MJO might do its thing. This is called outgoing long-wave radiation prediction, just sunlight reflecting off the ocean surface. If you have high pressure, right, high pressure makes cloud-free skies. You get a lot of sun beating off the ocean, reflecting off it, and you get these yellow things like that. That would be the inactive phase of the MJO. The active phase of the MJO produces clouds. The blues are negative anomalies, less sunlight bouncing off the ocean surface. So, let's get ourselves oriented here. South America, Central America, Hawaii, New Guinea there, dateline 180 right there, Equator right there. So the Kelvin wave generation area right here. It looks like the active phase of the MJO is over the maritime continent. A week from now, 5 days from now, trying to seep into the West Pacific, continuing 10 days and 15 days out, but not a strong signal and just barely easing into the Kelvin wave generation area. This is per the statistic model. The dynamic model, like the GEFS model right there, just an ensemble version of the standard GFS model, pretty much says, no, that's not going to happen, just a dead neutral pattern. So a little bit of back and forth on how this is going to play out. Let's dig yet a little deeper. Phase diagrams for the same two models, statistic model, dynamic model, help give us a little bit idea of what mechanically is really going on here. Now, how do you read this chart? Very strange looking chart, but assume this: the active phase and the inactive phase move from west to east, from the Indian Ocean to the maritime continent, to the West Pacific, to the East Pacific, under the United States, across the Atlantic Ocean, over Africa, back to the Indian Ocean. Heavy dot is where the active phase is right now. So in the East Indian Ocean, here's the forecast track, 3 different versions of it. All have it dumped somewhere over the maritime continent, like Bali, and exceedingly weak. The further the dot is away from this circle, the stronger the active phase is. So a very weak active phase and not really doing a whole lot. And also, just a case in point, seems like the MJO is strongest in the fall and winter months into spring, and then is weakest in the summer months, late spring into summer. Now, the dynamic model over here has the active phase, weaseling into, this really would be the West Pacific, but if you're outside of, or where this line is considered very weak, the circle here, if you're out here, it's very strong. You want to see the active phase like up here. But following this forecast track, it's exceedingly weak in the West Pacific, and that's probably to be expected given the time of year. Now, the upper level model, which is a statistic model, this shows areas favorable for precipitation. One can loosely equate that with the active and the inactive phase of the MJO. Reds and yellows, inactive phase, dry air; greens, wet air, active phase of the MJO. So this goes out 40 days, 5 days each panel. South America, Central America, Hawaii is the pixel right there. New Guinea there, the equator there, the date line there. This shows wet air building over the Kelvin wave generation area. Active phase of the MJO, pushing across the Pacific and into probably the East Pacific about the end of June, June 28th, then pushing into Ecuador through the first week in July, and then gone, with the inactive phase starting to materialize in the far West Pacific in early July, and then pretty much in control. So June, for the most part, looks like active phase, though we kind of know it's already pretty weak. And then July looks like it's going to be a period for the inactive phase. So if you're going to take a vacation or something like that, I don't know that you have to worry a whole lot about some mega swell happening till maybe the end of July, at which point the El Nino signal, I suspect, is going to start getting much stronger in the Pacific down south. And then the potential for storm production could increase. And one more model, the CFS model, going out a month here. Same deal, the east-west component of the wind, the blues, easterly anomalies, the inactive phase, and you actually see it here, the dotted contour. That is the inactive phase. The solid contours, the active phase, and the reds are westerly anomalies. That's what we want. Again, they feed energy to the jet stream. So, and the Kelvin wave generation area starts about 125 east, so right about there. This is past performance. There's that last big mega strong active phase, the MJ. We saw another one there back in April as well. Current situation, well, here's the inactive phase, the dotted contour, just easing into the Kelvin wave generation area, but it's supposed to all fall apart in a couple of days. Mix of the blues, easterly anomalies, and westerly anomalies, so not too much of a signal. And then once you get to the end of June, westerly anomalies take over. Not strong, but just moderate westerly anomalies. Supposedly there's some little hint of maybe the inactive phase even here, but I think that's probably an anomaly. And then finally, the CFS model going out 3 months. The forecast, this is reversed here. Forecast up top, past performance down here. Yeah, and this is the east-west component of the wind. The yellows, westerly anomalies, the blues, easterly anomalies. So you can see there was certainly looks like active phase of the MJO here back in February, another in April. We talked about that. A stronger one in May. And then here we are today. Oh, and let's get West Pacific starts about 125 east. So the Kelvin wave generation is from here to about here. So draw a box right there. The clear thing that shows up, westerly anomalies, well, a little pocket of easterly anomalies, but mostly westerly anomalies in the Kelvin wave generation area. Then when you get to July, it's just steady westerly anomalies, just taking control, where notice there was sort of this regular pattern in the early part of the year, active, inactive, active, inactive, active. Then it just looks like it's steadily active after that. That is clearly the building El Nino signal. Let's overlay the MJO, just sort of get a sense of what's going on. Solid contours, active phase. Okay, this is pretty much like what we thought it would be. The westerly anomalies, active phase. Easterly anomalies, inactive phase back in March. Another active phase back in April. Inactive latter half of April and early May. The most recent active phase here in May. Right now, but here, notice this. Things get weird. Inactive phase is setting up, but westerly anomalies forecast continuing. That's a clear El Nino sign when you just have westerly anomalies during both the inactive and the active phases. The inactive phase, they call it, it destructively interferes with the El Nino base state. That said, it still produces westerly anomalies. And then when you get a real active phase, and look at this, there's one forecast starting in July, and it just goes the whole way through the rest of summer into the beginning of fall. And it like amplifies the El Nino base state, just producing more westerly anomalies, and then it's just massive Kelvin wave production and draining every drop of warm water there is in the maritime continent and start shoving it towards the U.S. West Coast to feed the El Nino machine. Let's overlay the low-pass filter here. Now this really tells the story. The dotted contour, like the inactive phase here, you know, that we were looking at, this is like the La Nina is like a long-running inactive phase. This is the La Nina signal that was in control back in January, February. It's just withering, fading, and moving over California and all but gone, while this mega low-pressure system, or low-pressure bias, really, the El Nino signal that's been over the maritime continent is moving now clearly into the Pacific Ocean. Do a little analysis here. The core of it right today is about 170 east, almost on the dateline, with the leading edge of it at almost knocking out, certainly over Hawaii and pushing towards California. Notice a third contour forecast developing by the end of June. That in turn will feed these westerly anomalies, and then you get the active phase constructively integrating with the low pressure bias here, and that just feeds the wind machine. And the closer you get into fall and the active phases of the MJO are already starting to build and feel the roads, then the machine just really fires up. And the assumption is that El Nino will be well coupled with the ocean, and it will just be a storm producing machine from really sometime in July the whole way through the rest of winter into next year, the spring of next year at least. All right, enough MJO discussion. What's going on in the ocean? We've talked about all these Kelvin waves and theoretical warm water moving around. Is it really happening? We start by looking at the TAO buoy array, these series of buoys strung across the equator in the Pacific, specifically to search for Kelvin waves and detect them. So what do we have? See these little lines here? There's actually some over here too. These are the anchor lines on the buoys. The X's are sensors on those anchor lines. They collect data, use a model to fill in the gaps, and you get a profile of what the warm water and cold water movement's doing in the Pacific. 30 degree isotherm. We haven't seen this in years in the Pacific. It's building in. It was barely just a couple of pixels on the chart, maybe a month ago. Now it's pushing the whole way to, what is that, about 173 east. The 29 degree isotherm, you can see it almost reaching to 138 west. Lots of warm water here. The 28 degree isotherm, this is centigrade by the way, so temperatures, warmer than that by some degree, to 110 west. Point being, warm water on the move and pushing off to the east. But that's just actual temperatures. It's the anomalies. Notice the theme here, the anomalies. What's different from normal for this time of year? You can clearly see a river of warm water pushing across the Pacific. This is the isotherm here that the Kelvin waves follow. They fall over the maritime continent into the Pacific Ocean. They hit the isotherm, travel across, and you can see it here, just lifting to the north and to the surface. And as they lift to the surface, because there's less room there, those temperatures get concentrated. And then you get these super hot temperatures, 5 degrees centigrade. That's like 8.5 or 9 degrees Fahrenheit above normal, and not over a little area. This probably goes the whole way from Equator, which is off the chart here at 80 west, whole way back to 135 west. I mean, this is a lot. This is multiple Kelvin waves all backed up and just stacked there. It's like a traffic jam of Kelvin waves. I think it's at least four of them right there, all piled up, slowly erupting to the ocean surface. Here we go, Kelvin wave number 5. This is from a active phase of the MJO in April. You can't see it, but off the chart here in the next chart, then Kelvin wave number 6 developing. In fact, let's go take a look at that right now. Here we go. So here's that big backup. There's a little bit higher resolution data. It doesn't use the buoys. It uses satellites and some fancy technology. We'll look at that in a second. But you see the same pattern. Kelvin waves or warm water spilling down into the West Pacific, follow the thermocline across, and then as they start lifting up because of less water space here, they get concentrated and the temperatures just jump. This is what, 5 degrees above normal. That's 10 degree above normal Fahrenheit water temps. All right, so multiple Kelvin waves there. Here's another developing Kelvin wave. This is from back in April, and this bit falling here is the new one that was developed just in May. It'll show up probably a lot clearer as we get 4 or 5 weeks out. Again, it takes 3 months to go from somewhere over here over to here. So quite a lot of warm water in the pipe. And here's the sea level anomaly chart, that satellite data I was telling you about earlier. This is not temperatures, so it looks like it. Oh, and let's get oriented here. There's Chile, Peru, Central America, Hawaii. There's some pixels right there. Right there, that line, that's the date line. This is the equator here. That's New Guinea there. So what this is all about is satellites rotate polar orbit around the planet. It just rotates like that, and the Earth moves. Whoops, let's see. It rotates around the planet like that. The Earth rotates under it. After about a week, you get a image of every square inch of the oceans, of the surface of the ocean, and this measures the height of the ocean. You strip out the waves, strip out the wind waves, strip out the tides, and you just get a sense of, is the sphere of the ocean higher or lower than normal? And you can clearly see it clumps in places. Why does it do that? Well, warm water at depth expands, and as it expands, it'll create a bump on the ocean's surface. Cold water at depth contracts, it'll create a divot. And what we see here, well, there is Ecuador, and there is the Galapagos there, and there's the equator. +5, +10 centimeter anomalies, lots of warm water, and you can see it pushing from the maritime continent. There's New Guinea there, works its way over New Guinea, starts falling to depth, creates a big pool of water. This is that Kelvin wave number 5 right here, building with 10 centimeter anomalies, and then it follows, driven by Coriolis force, follows the thermocline across the Pacific, slams into the Galapagos and Ecuador, and here's that big ball of 5 and 10 centimeter anomalies here. Lots of warm water. It impacts the coast and then spreads north and south, and this clearly is the beginning signs of El Nino. So what's going on the ocean surface? We're looking at sea surface temperature anomalies, the difference from normal for this time of year. So I disappeared for 3 or 4 days and was off the grid, and it was like, yeah, El Nino's kind of doing something, but it's not like really growing very much. And it was kind of like, we'll see what happens. I think one of the last videos or two, it's like, well, is anything really happening, or has it kind of stalled? Come back, and then, oh my goodness, look at this. It's like all of a sudden temperatures start cooking here. This is much better than what we were seeing even a week ago. And we kind of knew it was happening. We knew there was a big Kelvin wave and it was going to start impacting. And clearly that's starting to happen now, with temperatures jumping along the coast of Peru and over the Galapagos here. But the other thing that was super noticeable is, so this warm water here gets caught. The high pressure up here drives the trades, starts dragging it across the equator here. But that had only made it to about 145 west. Come back 4 days later, and all of a sudden it's out to like 165 west. So a significant expansion of the warm water footprint on the ocean surface. It's also building north and south too, and you can see it whole way up here into Baja, getting more dense in this area, and certainly holding all down in here. So the El Nino signal, or the machine, certainly is looking good. Now, the sea surface temperature trend for the past 7 days, it just shows the areas where the water is warm, and you go, well, this doesn't look like anything. And that's, that kind of bothered me for a little bit. And then I thought about it and go, well, these temperatures are about as warm as they can get, and they've been close to that. So wouldn't expect to see a whole lot of warming. You see little bits of warming here around there, but not a wholesale warming. That said, it's all about as warm as it can possibly be. And then here's the overview again. You just see this. This is quite impressive. And what's really impressive about it is we're at June 11th is data from the 10th of June. You wouldn't normally even see things like this until August or something like that in just a normal El Nino. The sense is that this could be something more, and maybe much more than just a regular El Nino. But for now, we'll call it a regular El Nino, but we'll dig a little bit more into that in just a second. The Nino 1.2 region is that area where the super hot temperatures were just along Peru and Ecuador. Temperatures today, 2.629 degrees centigrade above normal. Okay, half a degree above normal is El Nino. We're cooking here, but it's not the Nino 1.2 region that really drives the machine. That's just sort of like the early warning area. Once these hot waters get dragged by the trades over into the middle of the equator, so the Nino 3.4 region, the area south of California out to about the dateline on the equator, that's what really matters. Again, the half a degree right there, that's the threshold for El Nino. We had maybe 1, 2, or maybe 3 days of that back a couple of weeks ago or a month ago. And now, though, steadily we've had this, I don't know how many days it is, 15, 18 days, something like that. Temperature's dropping a little bit right now, 804 thousandths of a degree above normal, but clearly in the El Nino range. So let's do a quick comparison here. This is sea surface temperatures as of yesterday. The sea surface temperature anomaly. Also note the amount of heat here in the Atlantic. There is a lot of chatter amongst the climatologists and PhD meteorologists about how much warmth there is in the Atlantic and the Pacific, and even to a certain degree the Indian Ocean, and how that will contribute to the El Nino development situation. Clearly, warm temperatures here extending the whole way out to 165 west, and really the whole way across the Pacific. Impressive. Now, the gold standard for El Ninos in my book is the 97 El Nino. The 82, 83 would have fit that too, but they didn't have the high res, the 5-kilometer resolution satellites back in 82, 83. They didn't have anything. We were using sticks and stones during that El Nino compared to where we are now. So compare this to the 97 El Nino. This is June 10th of 97. And look, we had a good footprint here. Notice the ocean's considerably cooler. People are trying to figure out exactly why that is. But still, the El Nino signal, if we just keep our eyes right in here, pretty strong. We're just going to go back and forth. So we see, yeah, this year's El Nino maybe not quite as intense right here, but that could simply be a function of, well, a Kelvin wave is just starting to erupt, and this will all fill in 2 weeks. Let's go back to 97. The warm signal goes out to 165 west, just like it does today. And how about the thickness of that? Well, let's look right in here. We'll go that, compare that to here. Actually, the 97 almost looks like maybe a little bit hotter in pockets along here, but maybe not as broad. Hard to tell, and especially with all this background heat. And notice the heat going the whole way down to 20 south and up to about 10 north, whereas in 97 it was barely 10 south, not nearly as advanced as it is now. Probably at this point I'd say it's a wash. We're on track with the 97 El Nino, and that was quite an El Nino indeed, so we'll keep our eyes on that. And let's just do a quick comparison. Here's today's El Nino. Where did the 97 El Nino go when it peaked out? There you go. Lots of cooking temperatures. Now notice the footprint, though, really wasn't as big. It almost seems like from an aerial coverage perspective, this year's El Nino might be, well, it's hard to say whether it's going to get as warm as the 97 one when it peaked in December. This is December 1st. But clearly the signal is in the ballpark. It just needs to get warmer. But we know we got multiple Kelvin waves coming, multiple active phases of the MJO. So this is June. Let's see, June, July, August, September, October, November. 6 months still of building to go. There also could be 6 months of it all falling apart. Probably not, based on where we are. Once the atmosphere and the ocean get coupled, they're sort of working together as a team, then this thing starts amplifying. We're in the very embryonic stages of El Nino development, and so far, things looking pretty impressive. All right, so Speaking of being coupled, what does the atmosphere think is going on? Is it sensing that El Nino is building, that some sort of thing is happening that it needs to respond to? So we look at the Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. Tahiti over the Pacific, Darwin roughly over the Indian Ocean or maritime continent. When pressure is lower in Tahiti relative to Darwin, this index goes negative. Okay, when it's negative, that's a sign of either the active phase of the MJO or the development of El Nino. Okay, when it's positive, that means pressure is higher over Tahiti than Darwin and means the center of low pressure is maybe in the Indian Ocean somewhere. Today, we are positive at 10.54, but look at where we were just a week ago or so, minus 29, minus 64, and another minus 28. We've had a good run of the active phase of the MJO, and we know now that we are in the inactive phase right now. It would not be surprising to see this creep up a little bit. Now, the 30-day average SOI takes the noise out of some of this and gives you more of a sense. It's a 30-day or 15-day minimum delay, but it gives you sort of active-inactive phase of the MJO thing. We're at minus 15.17, but we were up at 19.64 a week ago, let's say. So this was probably the peak or the tail end of the active phase of the MJO. And where were we a month ago? Minus 5.68. This trend certainly moving in the right direction, suggesting that low pressure is building over Pacific and high pressure is building over the Indian Ocean, a clear El Nino indicator. Now, the 90-day average is another way of looking at this is like the MJO indicator, active phase, inactive phase. This takes all the noise out of it and just gives you a general trend is lower pressure building in the Pacific. Today's value, minus 6.8. We were up to, about minus 7.57 a week ago. But prior to that, a month ago, we were about dead neutral. So this clearly indicates that something's happening in the Pacific. The pressure is lowering and at times lowering dramatically, suggesting a building low pressure pattern over the Pacific and not in El Nino territory yet. But when this starts hovering in the minus 10 to minus 15, and this guy's in the minus 20 range fairly consistently, then you're deep in El Nino. We wouldn't expect that until we get into maybe November or something like that. And then finally, the sea surface temperature forecast for the Nino 3.4 region, that area south of California on the equator out to about the date line. From the CFS version 2 model, this is the U.S. main long-term ENSO model. This tells us, well, let's see, we are in June, so these lines here like mid-April, mid-January, so mid-June would be roughly here. Suggest temperatures about 0.7 of a degree, and I think we're at 0.8 right now. Okay, by July, now this is the raw data. It says temperatures going up to about 1.2 degrees above normal. Half a degree above normal is the El Nino threshold in this area, and then up to about 1.9 degrees as we get into fall and winter. Clearly, that's El Nino territory. Now, not as high as this was. It was up at 2.2 or maybe even 2.3 degrees above normal, and this is the raw data. The PDF corrected is probably a little bit more of a conservative view. It shows temperatures at about 0.95 of a degree as we get into mid-July, and then up to 1.6 degrees as we get into winter. This model had been, more on the high end of all the ENSO models that are out there. Now it's sort of falling in line with the others. That said, my personal opinion, just what I see developing on all the other charts, what's really happening versus a computer's made-up version of what might happen, I think this is definitely on the low side. I think this might even be somewhere, I suspect we're heading into super El Nino territory. A lot of the PhDs suggest that as well. No one will commit to it. I'm not committing to it either, but it would not be unreasonable to expect probably 2.1 or 2.2 degree temperatures. I think anything at 2 or above is super El Nino, and it just, given where we are this time of year, it seems very likely that we're heading in Super El Nino direction. So let's wrap this all up in a ball. What's happening right now surf-wise? Well, things pretty quiet. I mean, we're sort of in the doldrums of summer, if it's kind of early for that, but that's where we are. I think what's really going on, it's the transition from, I'll call it ENSO neutral to El Nino. The momentum in the atmosphere is not really building. When you're sort of in the dead zone in the middle, one would say, oh, it's neutral. Things should be pretty much like normal. But we're clearly, like, the pendulum is swinging from one extreme, which was hard La Nina for 3 years. Now it's swinging, I believe, hard towards the El Nino side of things. As we get over the threshold, give it about another month and a half, I suspect we're going to see a significant uptick in swell production and storm production in the southern hemi, and that will lead us right into the start of fall, and I think it's going to be an early and an intense fall, and then just getting heavier from there. But that's all rampant speculation right now. Immediately, though, no clear signs of any significant class swells. In fact, literally, there haven't been any significant class southern hemi swells so far this year. I don't know that typically in the May to June-ish time frame is when you see into up to about the 4th of July. So when you see a lot of really heavy surf production, we haven't had any of that. So the lackluster summer is following a lackluster winter, which is not surprising considering that La Nina has been in control. But the expectation is as we get in the later part of July and from then on, things are going to pick up. As El Nino gets a better footprint, you'll see that SOI index start falling negative, and then you'll know for sure that the atmosphere is coupled with the ocean, and then with more Kelvin waves on the way, it's only going to get more intense from there, assuming the models are right. But even right where we are right now, just looking at objective hard data that's happening, the atmosphere is definitely changing, definitely moving in an El Nino direction, and not lightly. It's firmly in that court and moving more that way. So I think the thing is, take care of business now. Do what you need to do. Make sure you are training, because come about a month or two from now, the time for training will be over, and then it'll be time to execute, and you better be prepared for it. Get your boards lined up, get your guns set up for the winter, all that kind of stuff, because you're going to need it. All right, so that's the video for this week. We'll do it again next week. If you enjoyed the video, give us a thumbs up. Like and subscribe. It's nice if you haven't subscribed, subscribe. It helps us and sort of gives us a little bit more favorability with the Google Analytics machine and dribbles a little bit of money our way. If you'd like to donate, that's okay too. The special thanks button, the heart with the $sign in it, that's appreciated as well. We really do appreciate everyone's contributions to date. The response has really been amazing, so thank you so much. And with that, we will do it again next week. Same time, same channel. Thanks for watching.